Hello everyone. Let's start collision. This collision will be completed in one single video, so it will be a bit longer than expected. Here, collision can be divided into two different nature. First type will be elastic collision, where kinetic energy and linear momentum will be conserved. And what about the inelastic collision? In this type of collision, kinetic energy will not be conserved, whereas linear momentum will be conserved. Before collision and after collision, they will have different kinetic energy, but in the case of elastic collision, they will have the same kinetic energy before and after. There will be no loss in the kinetic energy, and both this collision, elastic collision or inelastic collision, will have this linear momentum conserved. Linear momentum will be conserved in both this type of collision, and the only differentiating feature between elastic collision and inelastic collision is the loss in the kinetic energy. If there is loss in the kinetic energy, it will be inelastic collision, and if there is not a single loss of kinetic energy, then that type of collision will be elastic collision. And you should know one more subclass of this inelastic collision, that is perfectly inelastic. And for this perfectly inelastic, after collision, the two colliding body moves together as one single object. Let us suppose this is mass m1 and this is colliding with mass m2, and after collision, if this m1 and the m2 moves together as a single object, then this type of collision will be known as perfectly inelastic. And before starting our question, we have to understand some basic concept along with its formula. For elastic collision, there must be conservation of kinetic energy and momentum. Here, let us consider this very important formula. Let us suppose m1 and m2 are two colliding body, and initially they were moving with a speed of u1 and u2 respectively, and after collision, the two colliding body moves with velocity v1 and v2 as it is written in the formula, and we must have u1 greater than u2, and for after collision we will be having v2 greater than v1. In order to understand this concept, you have to use the common sense. Here, m1 should have a greater speed than m2. Why? Because if m2 is faster than m1, there will be no collision at all. Therefore, m1 must have more speed than that of m2, and after collision, in order to avoid any further collision, m2 must drive faster than m1 after collision. Okay, and we will be having the second most important formula, that is coefficient of restitution. This is very important. What do you mean by this coefficient of restitution? It is nothing but it is the ratio of relative velocity of separation. This is relative velocity after collision divided by relative velocity before collision. And we do know that if two particles are moving in a same straight line, then what will be the relative speed? Relative speed will be simply the difference. Here, after collision, which one will be having greater speed? m2 will be having greater speed than that of m1. That is why relative speed will be v2 minus v1 divided by, what about relative speed before collision? We know that m1 will be moving faster than m2, therefore it will be u1 minus u2. You have to remember this. And depending upon the value here, E is equal to 1. If E equal to 1, that means it will be perfectly elastic. Remember this, perfectly elastic. Okay, for perfectly elastic, coefficient of restitution will be equal to 1. And for elastic collision, in elastic collision there will be conservation of kinetic energy as well as conservation of linear momentum, and after putting the after applying your conservation of linear momentum formula and kinetic energy formula, we do get the final velocity v1 and v2 as this. v1 will be equal to m1 minus m2 into u1 divided by m1 plus m2 plus twice m2 u2 divided by m1 plus m2. And what about v2? v2 will be this much. You have to remember the formula anyhow. You have to remember this formula. Okay, that's your job. Now after knowing this formula, after keeping all this formula in our mind, let us start with our question number 66. For this question number 66, a body of the mass 4m is moving with a speed u collide with another body of the mass twice m at rest. Here, before collision, let me write over here, this is question number 66. Before collision, this is 4m and it was initially moving with a speed u plus. And what about this second mass? This is twice m. This is body A and this is body B. Body B is at rest, so this is twice m will be at rest, so it will be having zero speed. After the collision is head on and elastic in nature, that means there will be conservation of the body of the mass 4m moving with a speed u collide with another body of mass twice m at rest. The collision is head on and elastic in nature. After the collision, elastic means there will be we will be having this 4m will be moving with velocity v1 and another will be twice m moving with velocity v2. Initially the body B was at rest, but after collision this body B will be also moving with velocity v2. Okay, after collision, the fraction of energy lost by the colliding body A, that means what will be the initial kinetic energy of A? The initial kinetic energy of A will be very simple. It will be half into 4 into u square. And what will be the velocity of this particle A after collision? This will be v1. So we have to first find out the value of v1. If v1 is to be find out, what is the formula? Let us just put over here. v1 is equal to how much? For question number 66, v1 will be equal to how much? We are applying this formula. What is m1? m1 is 4m minus what is the second mass? Second mass will be twice m divided by total mass. Total mass will be 4m plus twice m. And what about the initial speed? That is speed of the first particle. Speed of the first particle is given as u. And what about the second? This will be twice 2 into twice m into this will be 0 divided by 4m plus twice m, because the second particle was initially at rest. Therefore we have to take u2 equal to 0. So we can ignore this step also. Therefore we will be having our answer as twice m divided by 6m into u. Answer will be u by 3. So final velocity comes out to be u by 3. So the change in the kinetic energy or loss in the kinetic energy will be loss of kinetic energy for particle A. For particle A will be very simple. It will be half into 4m into what is initial speed is u square u. And what about the final? Final will be equal to 4m into this is u by 3 holding square. And after simplification we will be having 2 half into 4 by m into this will be u square minus u square divided by 9. So answer comes out to be 1 by 4 1 by 2 into this is 4m into 8u square divided by 9. So answer will be 8 by 9, and here this is equal to 8 by 9 into half into 4m into u square. This is equivalent to your initial kinetic energy. Okay, so our answer will be 8 by 9. Our answer will be 8 by 9. This is 8 by 9 into initial kinetic energy. That's very simple. Our answer will be option number C. Now let us start with our question number 67. A moving block having mass m collides with another stationary block having the mass 4m. The lighter block comes to rest after collision when the initial velocity of the lighter block is v, then the value of coefficient of restitution. Anyway, I will draw the diagram. Collision diagram will be like this. What was the initial mass? The initial mass, moving mass, will be m. For this question number 67, we have like this, mass m, and it was initially moving with a moving block having mass m collides with another stationary block having mass 4m. This is 4m, and this 4m is at rest. The lighter block comes to rest after collision when the initial velocity of the lighter block, that means initially it was moving with velocity v, and after collision this m comes to rest. Read the statement very carefully. The lighter block comes to rest after collision. That means here m will be at rest. And what about the 4m? We do not know it. 4m will be moving with some another velocity. Let us put this to be v2. Okay, and we have to find out the coefficient of restitution, and for finding the coefficient of restitution we have to know the respective velocities before collision and after collision. And let us read the question very carefully. What type of collision is it? Here in this question number 67, particular type of collision is not mentioned, so we cannot assume it to be elastic collision or inelastic. It is not specified, so the only formula that holds true for elastic or inelastic collision will be conservation of linear momentum. Therefore we will be using conservation of linear momentum. By conservation of linear momentum, that means what I am trying to say is that we cannot use the formula v1 is equal to m1 minus m2. The formula which we have used in the previous question cannot be used here, because the previous formula will be applicable only for elastic collision. Therefore we will not be using that formula for this question number 67. Rather, we will be applying conservation of linear momentum, which can be applied for either of the collision. In what is the initial linear momentum before collision? It will be mass into velocity v plus this will be 4m into 0 equal to linear momentum after collision. It will be m into 0 plus this is 4m into v2. We have to find out the final velocity of 4m, and here this will be mv equal to 4m v2. So this m and the m get cancelled out, and finally we get our velocity v2 equal to v by 4. So if you get the velocity v2 by 4, we can easily find out coefficient of restitution, because we know that for finding out coefficient of restitution we must have respective velocities before collision and after collision. Before collision it is already given, and after collision one of the velocity is given. One of the velocity is given as 0 because m comes to rest. And what about for m? We do not know it. So for m moves with a velocity v by 4, therefore coefficient of restitution E will be equal to, we have this v2 minus v1, relative velocity after collision divided by relative velocity before collision. And we have, what is v2 is v by 4 minus, what about v1? This will be v1. Okay, this v1 is equal to 0, so v1 is 0 divided by, what is u1? u1 will be equal to, here u1 is equal to v, so this will be v minus. And what about u2? u2 will be equal to 0, so this will be equal to 1 by 4 of v divided by 4v, and this get cancelled out, and our answer comes out to be 1 by 4. And let us check out the option. Our option comes out to be, this is 0.25, which will be option number B. So this is the way to calculate our coefficient of restitution. First of all, you have to find out the different velocities before and after collision, and once you get different velocity before and after collision, you can find out a coefficient of restitution. Next, question number 68. A bullet of the mass 10 gram moving with a horizontal speed 400 meter per second strikes a wooden block of mass 2 kg which is suspended by a light inextensible. This question number 68 is very important. Without reading the question, I will just explain the two different conditions that can be arise from this question number 68. Here the two cases will be like this. This is freely suspended body of mass m. Initially it will be just 1 second. Initially this mass m is hanging from this fixed point with the help of a string, and we have this bullet of mass m moving with its velocity, initial velocity u, and this bullet will be will strike this hanging mass capital M, and after hitting this suspended mass capital M, there will be two cases. The case number 1 is that this bullet cannot penetrate this wooden block, and as a result of the momentum of the bullet, this bullet will get stuck inside the wooden block, and these two will move together as one single system, and it will rise up to a height h, and the height is to be find out. And for finding out this height, it is very simple. We can easily find out the height just by knowing the combined velocity of this wooden block along with the bullet. Initially it was only hanging mass capital M, but after striking with the bullet, the total mass will be M plus M, and after striking it, both this bullet and the wooden block will move together as one single object, and it will rise up to a height h, and this rise in the height h is due to the momentum of bullet. And what about the case number 2? For case number 2, it is also very simple. In this case, we have to consider that after penetrating this hanging mass capital M, bullet moves with velocity v2, and this hanging wooden block moves with velocity v1, and it is raised up to height h, and this height h will be equal to v1 divided by 2g. So we have to find out the velocity of this hanging mass after penetration, and its value will be v1. So if v1 is known, then we can easily find out the height up to which this hanging wooden mass rise by how much? That will be v1 square divided by 2g. Okay, and what about your case number A? In both the case, what is the similar formula? The similar formula is that whether the bullet penetrate or whether the bullet is embedded in it, it doesn't matter. We have to find out the velocity of the wooden block. For the first case, we have to find out the combined velocity of wooden block and the bullet, and once we get this velocity v1, height is very easily calculated by using v1 square divided by 2g. Let us read the question. For this question number 68, what is the mass? Mass is given as 10 gram, and horizontally with a velocity initial velocity of the bullet is given, mass is also given. Strike a wooden block of mass 2 kg, and capital M is also given, is suspended by a light inextensible string of length 5 this is 5 meter. Okay, this is 5 meter. And what about this small m? And this small m, mass of the bullet is given as 10 gram. Mass of the bullet is given as 10 gram. 10 gram can be written as 10 into 10 to power minus 3, and this will be 10 to power minus 2 kg. And what about the initial speed of the bullet? Initial speed of the bullet u is given as 400, not 800, it is 400 meter per second. And what about the hanging mass capital M? Capital M is given as 2 kg. It is given as 2 kg. As a result, the center of gravity of the block is found to be raised. Center of gravity means this wooden block is raised by how much? Wooden block is raised by a vertical distance equal to 10 centimeter, and height h is also given as 10 centimeter, or we can simply write it as 0.1 meter in terms of our standard unit. Now the speed of the bullet after which it comes out horizontally from the block will be, that means we have to find out the v2, speed of the bullet after penetration. So for this question number 68, we have to consider the second case. First case is not being asked, and let us do for your second case. Both these cases will be solved by using our conservation of linear momentum. Let me erase this portion first. Question number 68. By applying our conservation of linear momentum, it will be like this. What is the initial momentum? Initial momentum will be mass of the bullet into velocity of the bullet u equal to there will be one more plus capital M into 0, because this mass M was initially hanging and it was at rest, therefore we have to put the value as 0 equal to what is the momentum after what will be the velocity of this block of mass M? It will be v1, so we can write M into v1 plus, and what about your v2? This will be mass M into, we have this v2, and if we know the value of our v1, if we are able to find out the velocity with which this hanging block is moving after collision, then we can easily find out our v2, because M is the value of M is known, u is also given, therefore the unknown parameter that is to be found out is v1, and this can be calculated from this given formula. Height h is equal to how much? We can apply the formula v1 square divided by 2g equal to 0.1, and what is the value here? We have v1 to be find out v1 square is equal to 0.1 into 2 into this is 10. So we will be having v1 will be equal to how much? This will be root over 2. This is 0.1 into 10 will be equal to 1. 1 to 2 will become 2. So v1 will be equal to root over 2. After collision, this wooden block of mass capital M will be moving with velocity v1 equal to root over 2. Once we get this velocity v1, then we can easily find out the velocity with which the bullet will be moving after penetration. It will be equal to v2. We just put the value over here. M is equal to how much? And here M is 10 to the power minus 2. We just put the value here. M is 10 to the power minus 2. And what about the initial velocity of the bullet? This is 400 equal to mass will be mass of the hanging block will be 2 kg into what about v1? v1 is root over 2. We just put it as root over 2 plus, and this will be 10 to the power minus 2 into v2. And after simplification we will be having 4. This will be 4 minus this will be 2 root over 2, and this will be 10 to the power minus 2 into v2. And here we do know that this 2 into 1.414, this is 2, this is 8 to 8, and this is 2. So we will be having 4 minus 4.000 minus this is 2.828. Our answer comes out to be 2, 1 in hand, 3, 7, and this is 9, 1 in hand. So we will be having 1.172, and this will be equal to 10 to the power minus 2 into v2. So if 10 to the power 2 is transferred in this direction, we will be having 117.2 meter per second, and this is equal to v2. We have to check it out in the option. So it is almost equal to C, 117. Here instead of taking the value of G as 10, you have to take the value as 9.8. only then you will get the correct answer. Okay, so our answer will be almost equivalent to 120. Let me change the value here, 9.8. you can calculate by yourself. Okay, you can put this as 9.8, and we will be having this as root over this will be 19.6, 1.96. we will be having 1.96 as our answer, 1.96, and answer will be 0.14. and you just put the value over here, and you just calculate by yourself, and you will get the correct answer. I hope you all understand this calculation. I will not be doing it because it will take 2 or 3 more minutes. That is why I will skip this one. You just try yourself by taking the value of G as 9.8, and only then you will get the correct option, that is 120. Okay, now let us proceed with the next question. For this question, next question will be question number 71. A ball is thrown vertically downward from a height of 20 meters with an initial velocity v0. It collides with the ground and loses 50% of its energy in collision and rebound to the same height. The initial velocity v0 will be equal to how much? Here for this question number 71, let me draw the diagram over here. What is the given height?